Welcome back to my YouTube channel. And today we are taking a look at Chapter 2, Form 3. And without any further ado, let's get right into it. The title for Chapter 2 is Standard Form. And this chapter is broken down into two different subtopics, namely significant figures and standard form, the title itself. And I will be teaching this topic in three different videos covering different aspects of this topic. The first one will be about significant figures. The second one will be about standard form. And the third one will be questions. In this video, I will be going over some questions regarding this topic and teaching you the right way of solving this in a methodical manner so that there is no way for you to make a mistake in this topic. It's very important to get a good understanding of this topic because this topic is more of the foundational level of foundational concept that is used over different topics. So mastering this is very important in the future. So let's get right into it. What are significant figures? The common mistakes most people do is they just learn a concept without understanding why it is used in the first place. Not just in maths, science, physics, biology, chemistry, in most of the scientific field, even engineering. Engineering is part science, physics, never mind, let's not get deep into that. So the problem that students face is they don't try to understand the concept on it as its whole. They just remember parts of the topic that are important to the exams. Of course, it will help you for your exams, but it's always better to understand it as a whole so that you can apply it in various fields, not just examinations. So for significant figures is mostly used in the scientific world as an estimation using approximation. This might sound a bit fancy, but bear with me. Significant figures is mostly used to show how accurate something is. So for example, in the scientific world, we use a lot of different measuring tools that measure liquids, that measure light intensity, that measure different things at different accuracies. For example, we have a common ruler, that's my best attempt at drawing a ruler. Please don't ridicule me, I'm not an artist, never was. So this is a ruler. So for a ruler, the significant figures will be 1.5, and that's it. We won't go more than this because we cannot measure what's in between of these lines because this corresponds to 0.5 centimeters and so on. So we would not go more than 1.5 because more than two significant figures, 1 and 2, because the ruler that we're using is not that accurate enough. But there are other tools such as the vernier calipers or the micrometer screw gauge, tools which I would not draw here because my drawings are not that good. If you would like to search the internet, be my guest and search for vernier calipers and micrometer screw gauge. These tools have a much higher accuracy measuring system, which will have more than two significant figures. So this is why significant figures are used to show how accurate something is. So the more the significant figures, the more accurate a tool is. Significant figures is something that is very commonly used in the scientific world. So now that we know why are significant figures used, let's take a look how to actually derive significant figures, or should I say, use the concept of significant figures. Let's begin. So for significant figures, we will have to deal with two different kind of numbers, which will be which are decimals and integers. Don't worry, we will cover them one by one. So firstly, decimal. Decimal is the easy one. So for decimal, we will have three parts. And let me go through one by one, or let me go through them one by one. The three parts will be three different types of zeros. Three different types of zeros. Okay. Zeros will be the tricky ones here. But before going into that three, it's important to understand one single thing. Every number, literally every other number than 0, everything else except for 0 are all significant figures, are all significant. All of them are significant except for 0. All are significant. So you see this 2 here, you see this 2 here, this 7 here, this 1 here. All of them are significant numbers. So when you calculate significant figures, you must count them in. So every other number than 0 will be significant. That's for sure. In any scenario, all of the numbers except for 0 will be significant. So for zeros, we have three different types of zeros. And all three of them can be found in this one decimal, which is, first, in a decimal number, the zeros in front, I should use a different color, I think orange. All the zeros before the first significant number, in this case, which is 2 is the first significant number. All the zeros before the first significant number will be regarded as not significant. These zeros are not significant. In a decimal, I repeat, in a decimal, the zeros before the first significant number are all not significant. And the second type of zero that we have will be the zeros in between two significant numbers. For example, here 7 and 1 are significant, and a 0 in the middle of them, in between them. This 0, however, will be significant. This is a significant number. This number will be significant. This 0 will be significant because it is between two different significant numbers. And the zeros, the one more type of 0 that we have is the zeros after the significant numbers. These two zeros. These two zeros are significant numbers as well. These are also significant numbers. So to recap, or should I say to summarize, in other words, all the zeros are significant unless they are in front of the first significant number. So how we would word it is, all the numbers are significant except for the zeros that come before a non-zero number in decimal. Yeah, that's a bit of a mouthful. I'll repeat it one more time. All the numbers, including zeros, are significant unless the zeros come in front. They come in front of a non-zero number in a decimal. That's it. So this 0 is significant, these zeros are significant, all of these numbers are significant, but the zeros that appear before a non-zero number, which can be 2, 3, 4, 5, 6, 7, 8, 9, and 1, all of this, if there's a 0 in front of the first non-zero number, all zeros in front of them will be regarded as not significant. That's it. As simple as that. If you do not understand what I meant, I will recommend you to watch this part of the video 2 more times, and by the end of the 3rd time, you'll understand this. If you don't understand, please do rewatch. It's very important for you to understand it. The moment you get the aha effect, you are safe. Trust me, rewatching this 2 more times will help you a lot in the long run. Because I used to have this problem which I only managed to solve when I was in Form 5, if I'm not mistaken. Form 4, Form 5. That's when I had the aha moment of like, oh, that's what it means. Because it's so just spare a few minutes and watch that part again if you can't understand it, so that you will have a better understanding for life. So now we're done with decimal, the easy part. Let's move on to integers. You might expect to see hard, but don't worry. Integer also easy lah. So let's have an integer. 6, 3, 7, 5, 5. So how many significant figures are is this number? You are correct. It's 5. 5 significant figures. 1, 2, 3, 4, 5. That's it. Simple. When you have 6, 7, 5, 0, 0, how many significant figures are here? Now, this is where students fail to understand. This number has 3 different answers. We can say that this has 3 significant figures. We can say this number has 4 significant figures. And we can say that this number has 5 significant figures. All these 3 will be acceptable under different circumstances. But if they just ask you for the significant figures for this particular integer, you can just say it's 3, 4, 5. Because zeros here can be considered significant and not significant depending on the question itself. So there is a gray area here where both of the answers can be correct. Not both, in this case, all 3 answers can be correct. I think it's better for me to show you a question regarding this so that you can understand this part. So zeros, when it comes to an integer, it is kind of a tricky situation. But before I forget, if this 0 appears in between 2 significant numbers like 6, 0, 5, 7, 2, this 0 is definitely significant figure. This is confirmed significant. So there are 5 significant figures in this integer. This is for sure. When the zeros appear at the end of the number, that's where you can have this loophole, or should I say this gray area, where it can mean all 3. All right. It's better for me to show you 3 examples so that you can understand this. But no worries, there will be more examples in the third part of this video, where we will go in much deeper and we will go through a lot of questions. Don't worry. So 3 examples will be shown. The best way to show these examples is by rounding it off. Rounding off these 3 examples. So firstly, we have rounding off an integer. So this bracket right here is the requirement. So the question wants us to round this particular integer into 2 significant figures and 3 significant figures. We will do it one by one. Firstly, 2 significant figures. So to calculate significant figures, always come from the left, not the right. We're not adding, we're not subtracting, always come from the right. So the significant figures will be 1 number and 2 numbers. So since 6 and 5 are significant figures, we just need 6 and 5 to be in that answer. So 6, 5. So what we do is, as usual, we will disregard the rest of the numbers. All of these 3 will be neglected. But before we neglect them, it's important to see whether this is more than 5 or less than 5. Since we know that this is more than 5, pardon me for my incorrect symbol. Since this is 7 is more than 5, we have to give 1 to the front, and 5 plus 1 we will have 6. So the answer for the first one will be 6, 6, and after being neglected, all of this will become 0, 0, 0. This might remind you of rounding off the number to the nearest 10,000, nearest 1,000, nearest 10, nearest 100. The exact same concept, there's no difference. So this number 66,000 is two significant figures because this is what the question required us to do. So for B, we have three significant figures. So same concept applies here. Let me erase this. Alright, so three significant figures. So let's go down the list. 1, 2, 3. So we need 6, 5, 7 in the answer. So same thing. The rest will be neglected. We will see whether this number is more than 5 or less than 5. And since 2 is less than 5, nothing goes to the front. We can plus 0 to it. So we will have 6, 5, 7, 0, 0. That's it for the three significant figures. So this is what I meant by these zeros can actually mean 5 significant figures, or 4 significant figures, or 3 significant figures according to the question. There is a higher chance that you get a question where they give you the integer and ask you to find this. This is the most probable case. It's a rare incident where you will get questions which will require you to answer whether this is 2 significant or 3 significant. Because the answer is a lot. For this, you can actually write 2 significant figures, 3, 4, 5, everything is acceptable. So getting this kind of questions in the opposite manner is not probable. It's not that probable during exams. But always keep in mind, if they ask you to go from here, they ask you to find the significant figures of this, all of these answers are acceptable. So we're done with integers. Now moving on to decimals. This is very similar to what we saw earlier. So now we have 2 significant figures. So what we should do is, again, count from the front. We have 1 and 2. Since we're only asked to give 2 significant figures, 1 and 2, and then the rest will be neglected. So before we neglect them, make sure to see whether this is more than 5, and it is more than 5. 8 is more than 5, and then we give 1 to the number 5, and we will have 66. So the answer is just 6, 6. You don't have to put decimal, because if you put decimal, and this 0 will be regarded as a significant figure, which will make it 3. So don't do that mistake. Just leave it at 66. Leave it as 66. That's it. And then B, we will have 1 significant figure. 1 significant figure. So what you should do here is same principle, same concept. You count from the front. Then they just need you to have 1 significant figure. So 1. So let's neglect the rest of the numbers. Before neglecting them, it's important to add to see whether this number is less than 5 or more than 5. It is 5. So 5 and more than 5 will be able to give 1 to the front. So we plus 1 to the front. Then 6 plus 1 is 7. And since 5 gave 1 away, so we have to neglect all of this. So we have 7, 0. We have 7, 0. Some might argue that this is 2 significant figures. Well, you are not wrong. This is the gray area where 70 is both 1 significant figures and 2 significant figures, depending on the question. But since we round it up, this is the best we can represent 1 significant figure in terms of 70. That's as simple as that. Moving on to the last example, we have third one. This is the 0.007256. So pop quiz. How many significant figure is this number? this number on its own, how many significant figures are there? Take your time to answer. If you need more time, just pause the video now. I will give you 5 seconds. 5, 4, 3, 2, and 1. So I hope you got the answer. The answer is 4 significant figures, because these numbers, these zeros, appear before the first non-zero number. Therefore, these are not significant. Alright, so the first significant number starts with the number 7. So the question demands us to write the answer in 3 significant figures and 2 significant figures. So let's begin. So the first significant figure is right here. Remember, there is no need for you to start from the first if it is not significant. You must start with the first significant number. So 7 is the first significant figure. With first significant figure. Number 2 will be the number 2. Then the third one will be the number 5. Then just we need 3 significant figures we have reached. Then the numbers behind it will be neglected. So 6 is neglected. So check whether 6 is more than 5, which it is. So we give 1 to the front, where you get the answer of 0.00. Retain the not significant figures. Just keep them there. They don't affect the result at all. 0.0072. 5 plus 1 will be 6. So this particular integer, this particular decimal, has a significant figures of 3. That's it. Please don't just eliminate them. Don't get rid of these zeros. Thank you. Make sure the zeros are inside the number, because having them tells us how accurate it is. Just keep them there. No worries. For the next one, we have B, 2 significant figures. We follow the same concept. Go one by one. 1 and 2. We will stop right here. Then the rest of the numbers will be neglected. In this case, 5 and 6. So let's see if 5 is more than 5 or less than 5. 5 is 5. So we will give 1 to the 2. Then 2 plus 1 we will get 3. So the answer that we will have at the end will be 0.0073. And there's no need to write the numbers at the back, because having them will mean 2 more significant figures. So just 73, 0.0073, and we have the significant figures of 2. That's it. No worries if you can't understand the complete gist of it. I recommend you to straight away go and watch the part 2 and part 3 video when they drop. I will be covering all possible questions, so that you always have a reference when you're doing the questions by yourself. So that's all for the first video. In second one, we will be covering standard form, and third one will be an overall overview and doing questions for both of these topics. So until I see you in the next one, bye bye, and thank you for watching.